How to check for linear dependence or independence of given vectors? The first point is, if you have dimension of a vector space over the field F as n, then n plus 1 vectors are always linearly dependent. LD means linearly dependent. Then if you have a set containing 0 vector, then that set is always linearly dependent. Set having only one non-zero vector is always linearly independent. Two vectors are linearly dependent if and only if one is a multiple of another. This is applicable only if you have two vectors. You have to check, are they multiples of each other. If not, then their vectors are linearly independent. N vectors of Fn are linearly independent. This is a method to check whether they are linearly independent or not. You have to evaluate the value of its determinant. The vectors form a matrix whose rows are the given vectors, then evaluate its determinant. If the determinant comes out to be not equal to 0, then the given vectors are linearly independent. If determinant equal to 0, then the vectors are linearly dependent. These points you have to remember before solving the problems. So let us go. The first point says that, see, for example, in R cube, any four vectors in R cube are always linearly dependent. Any 5 vectors in R power 4 are always linearly dependent. So if you know these points, that will help you to evaluate quickly whether the given vectors are linearly independent or linearly dependent. Let's see the problems. First problem, check whether the vectors, these are the three vectors given, are linearly independent or not. These are the three vectors in R cube. Therefore, if you have three vectors in R cube, you can always go with the determinant method. Write the given vectors as the rows of the matrix, then evaluate its determinant. So 1, 1, 1, 2, 2, 3, 1, 4, 5, 5. These are the rows of the matrix. Evaluate its determinant. 1 into 5 3 is a 15 minus 5 1 is a 5. Next, minus 1 into delete first row second column. 5 2 is a 10 minus 4 1 is a 4. Plus 2 into delete first row third column. 5 2 is a 10 minus 4 3 is a 12. So 15 minus 5 10. 10 minus 4 minus 6 here. Plus 2 into 10 minus 12 minus 2. 2 2 is a minus 4. 10 minus 10 equal to 0. If the determinant comes out to be 0, the vectors are linearly dependent. Now one more question. Check whether the vectors, two vectors in R cube, are linearly independent or not. So whenever you have two vectors, you can use that point. Uh, if one is a multiple of another, then the vectors are linearly dependent. Or else, one more method is form a matrix with the given vectors as its rows. Now reduce the given matrix to the row echelon form and check for 0 rows. If there are no 0 rows in the row echelon form of the given matrix, then the given vectors are linearly independent. If there is a 0 row, then the given vectors are linearly dependent. So that is another method. You can check, are they multiples of each other? That's one method. Otherwise, if you have more number of vectors, so in that case, you can always go with this method. So write the given write the matrix with the vectors as its rows. Now convert this matrix to the echelon form. If you don't know what are row echelon and row reduced echelon matrices, I have shared a link in the description box. Please watch that video. Now here are two changes to R2 minus 4 into R1. So that is a 4 minus 4 gives you 0. 5 minus 4 to is 8, that is minus 3. Minus 6 minus of minus here plus minus 6 plus 4 3 is a 12 is 6. So now this is in the echelon form. So there are no 0 rows, hence the given vectors are linearly independent because none of the vector is a multiple of each other. Next problem, check whether the vectors, these two vectors, are linearly independent or not. The same method I will apply, or else you can check, is one vector a multiple of another vector. See here. Actually, the second vector, this first vector is a multiple of second vector, that is 2 by 3 into 3, 6 minus 12. This is the method. Hence, they become linearly dependent. Or else, form a matrix with the given vectors as its rows. Now, 2, 4 minus 8, what I'll do is, I'll divide the first row by 2 and divide the second row by 3. So you'll get 1, 2 minus 4, 3 by 3, 1, 6 by 3, 2, minus 12 by 3 minus 4. Now I'll apply the operation R2 changes to R2 minus R1. So 1 minus 1, 0, 2 minus 2, 0, minus 4 plus 4, it is 0. There is a 0 row in the echelon form of a matrix. Therefore, the given vectors are linearly dependent. One more question. Here, four vectors are given. These are four vectors in R cube. We have the first point, n plus 1 vectors of the given vector space whose dimension is n are always linearly dependent. Here, 4 vector dimension of R cube is 3. Now, any 4 vectors in R cube are always linearly dependent. So, if you want to make sure, you can check with this method, you will get a 0 row in the given echelon form. Hence, the given vectors are linearly dependent. Fifth question, these are the 4 vectors in R power 4. So, 4 vectors in R power 4, you can use the determinant method. Determinant method is applicable only when you have n vectors in Fn. So, in that case only you can apply the determinant method. So, form a matrix whose rows are the given vectors 1, 2, minus 1, 0, 2, 1, 3, 1. Then 1, 1, 0, 1, minus 1, 3, 4, 2. Now, evaluate this determinant. So, to evaluate this determinant, it's a 4 by 4 determinant. What we can do is, we can apply the elementary operations. If you don't know elementary operations, I have previously made a video on elementary operation. That link is also shared in the description box. So please watch that video. So I will reduce this to the echelon form, then I'll calculate its determinant. So I will apply R2 changes to R2 minus 2 into R1, R3 changes to R3 minus R1, 1 minus 1, 0, and R4 changes to R4 plus R1. So that is because this is the first non-zero entry of the first row. Below, elements below the first non-zero entry should be made 0. That is made 0 by applying these elementary operation. 2 minus 2 becomes 0, 1 minus 1 becomes 0, and minus 1 plus 1, R4 changes to R4 plus R1, then it becomes 0. Why I am doing this? Because then you can evaluate the determinant along the first column, deleting the first column, first row, then you will get a 3 by 3 determinant. Then as per this 3 by 3 determinant, when you evaluate the 3 by 3 determinant, you will get the value of that 4 by 4 determinant. Now 1, 2, minus 1, 0. First row, there is no change in the first row. Second row, 2 minus 2, 0. 1 minus 2 to the 4. 1 minus 4 minus 3. 3 minus of minus 2. That is 3 plus 2 is 5. 1 minus 2 into 0, it is 1. Next 1 minus 1, 0. 1 minus 2 minus 1, 0. Minus of minus plus 1. 1 minus 0, 1. Next minus 1 plus 1, 0. It is adding now. 3 plus 2, 5. 4 minus 1, 3. Then 2 plus 0, 2. Now you have to evaluate this along this column. So delete this first row and first column. Then you will have minus 3, 1 into minus 3, 5, 1, minus 1, 1, 1, 5, 3, 2. Next you have to delete first column is already deleted. Second row. When you delete second row, 0 into any 3 by 3 determinant, it becomes 0. So that's why we may apply the elementary operation. Now evaluate this determinant. Minus 3 into 2 minus 3 minus 1. Minus 5 into plus minus plus. I hope you know how to evaluate a determinant. 5 into minus 2 minus 5, that is minus 7. Then plus 1 into minus 3 minus 5 minus 8. So this is 3 plus 7 plus 7 5 is 35 minus 8 1s 8. So 35, 38 minus 8, 30 not equal to 0. Exact value also you don't want there. You have to check is it equal to 0 or not equal to 0. Hence it is linearly independent. One more method is the same. This method also you can apply, but it takes more time than this. So it is better when you have 4 vectors in R power 4, it is better to apply with the determinant method. Or else you form a matrix A with the given vectors as its rows, then reduce it to the echelon form. one by one, that is after so many steps. You have to check for the zero rows. If there are zero rows, the vectors are linearly dependent. If there are no zero rows, then the vectors are linearly independent. See, after applying all these operations, I will get a row echelon form of the given matrix which doesn't contain any zero row. Hence, the vectors are linearly independent. So, it takes longer time than the previous method, and yeah, compared to this, the first method is easier and simpler. Next, one more problem. 1, 2, minus 1, 0, 2, 3. These are three vectors in R square. So you can directly conclude that these three vectors are linearly dependent because three vectors in R square are linearly dependent as one of the vector. We are not checking here for multiples. Whenever you have two vectors, you have to check are they multiples of each other. Whenever you have three vectors in R square, they are linearly dependent only because the one of the vector will be in the span of the other two, rest of the two. Hence, the it gets merged and you will get the vectors as a linearly dependent vectors. You can check with this method, making a matrix whose rows are the given vectors, then converting it into the echelon form, then you will get a echelon form with zero row. Hence, you can conclude the vectors are linearly dependent. So, this is how we will check for the linear dependency or independency of given vectors. I hope you understood the concept. Thank you for watching.